Okay, so in the last video, we had a look at the derivatives of sine and cosine and our e to the power of x function, okay? And they're going to be coming up a lot in what we do next, which is going to be what we call the product, the quotient, and the chain rule, okay? So if we start off now with what we call the product rule, okay? So we've got the product rule. And the product rule says that if you were to find the derivative of a function u times v, okay, so where u is some function and v is some function, okay, and you're going to find the derivative of those, that is going to be equal to u times the derivative of v plus v times the derivative of u, okay, and this is going to make more sense when we do an example, okay, so for example, we are going to find the derivative of, finding the derivative of 4x squared times by sine of 2x. Okay, so we are going to say, this is like finding the derivative of u and v, okay, but we're going to make u in this case equal to 4x squared and v equal to the sine of 2x. So we're splitting our function into two separate functions, and our two separate functions are our u and our v, okay? So we can now say that the derivative of u, well, that's going to be 8x, and the derivative of v from the last video, this is going to be 2 times the cosine of 2x, right? So we can now substitute these into our formula for the product rule. So if we come over here, we can say that the derivative of 4x squared times sine of 2x is going to be our u, which is 4x squared, times by our derivative of v, which is times in by 2 cos of 2x, and then we're adding on our v, which is sine of 2x, and we're timesing by our derivative of u, which is 8x. And if we simplify this down, we end up with 8x squared times the cosine of 2x plus 8x times the sine of 2x. And depending on what the question may ask, it may ask you to factorize it, or if you're to try and find critical points, and you might want to look at factorizing it to access the null factor theorem, you might bring a common factor of 8x out the front here, and say you get x cosine of 2x plus sine of 2x. And either of these answers here are perfectly acceptable, okay? So that's the product rule, okay? It's not too tricky in theory. We're just looking to separate our function that we get given and then substitute the values into the formula, okay? It's more this process through here where you're simplifying down and shuffling things around that's going to perhaps test your algebra skills, and that's where silly mistakes might come in, okay? So moving on from the product rule now, we will come back to it, okay? But we're now going to look at what we call the quotient rule. Okay, so the quotient rule. The quotient rule is similar, but rather than dealing with products where we're multiplying things together, we're dealing with things where we're dividing in our function. So this says that the derivative of u over v this time, okay, so when our function is something divided by something, this is equal to v times the derivative of u, take u times the derivative of v, divided by v squared. Okay, again, it will make more sense in an example. So let's say that we are asked to find the derivative of 2x cubed divided by e to the power of 2x. Okay, well, we can say we want to make these look the same, right? So we're just going to say that u is equal to 2x cubed and v is equal to e to the power of 2x. Well, we can differentiate u here and say that that's equal to 6x squared. And if we take the derivative of v, that's equal to 2e to the power of 2x from what we did in the last video. And if we substitute that into our equation for the quotient rule, well, we just say that the derivative of our 2x cubed divided by e to the power of 2x, that's going to be v, which is e to the power of 2x, times by the derivative of u, which is 6x squared, take away u, which is 2x cubed, times the derivative of v, which is 2e to the power of 2x, and we're going to divide all of that by v squared, which is e to the power of 2x times e to the power of 2x. Now, we could write that as e to the power of 4x, but you'll see why I'm not going to in just a second. So we can now simplify our numerator down, okay, so just write it 6x squared times e to the power of 2x, take 2x, oh sorry, that'll be 4x because we're multiplying those two 2's together, so 4x cubed times e to the power of 2x divided by e to the power of 2x times e to the power of 2x. Well, we can now take a common factor of e to the power of 2x out, okay? So again, it's not the substituting in or anything like that might be the tricky bit. It's more this that will get you unstuck, is testing your algebra skills. So if we take out a common factor of e to the power of 2x on the numerator, we get 6x squared take 4x cubed. And on the denominator, we'll take out this common factor of e to the power of 2x. And we're just left with e to the power of 2x, okay? So these e to the power of 2x's will cancel. Lots of e to the power of 2x's going on. And we end up with 6x squared take 4x cubed divided by e to the power of 2x. And that is going to be our answer for the derivative. Okay, so that's pretty much all it is for the product and the quotient rule. Okay, we'll do the chain rule in another video. But I just want to do a quick example of if we have to combine these rules together. So if we have to combine the product rule and the quotient rule together. So I'm going to take what we know for the quotient rule, okay, and I'm going to take this over, oh, lost it. Take this over here, okay, that's our quotient rule. And I'm going to take our product rule too. And I'll put that over here too. And we're going to come over this way, and we're going to do a question where we have to combine these two together. So for example, okay, again, it will make more sense what I'm talking about if we do an example. So we're going to try and find the derivative of 3 times the sine of 2x, and we will multiply that by e to the power of x, and we'll divide, sorry, rather than a multiply, I'll just put a dot there, and we'll divide all of that by x squared. So here we're going to have to combine our two theorems together. So if we treated this like we were to treat the quotient rule, we would say that u is equal to our numerator. U is equal to 3 sine of 2x times e to the power of x, right? And we would just say that v is equal to x squared. That's just doing the quotient rule. And we can take the derivative of v. That's no problem. We just say that that's equal to 2x. But we can't seem to take this derivative of u, right? It's still not in the form that we need it in, like a nice easy one like that v there. So we have to do the product rule on the u section alone. So rather than using u and v's, I'm going to use a's and b's here. And I'm going to say that a is going to be 3 times the sine of 2x. So this is to try and find the derivative of u. And we're going to say that b is equal to e to the power of x. Well, we can now take the derivative of a. That's no problem. We get 6 times the cosine of 2x. And the derivative of b, we just get e to the power of x. So when we do the product rule, and we introduce our product rule over here, okay, well, we do u times the derivative of v, or a times the derivative of b. So we get 3 times sine of 2x, so our a times the derivative of b, which is just e to the power of x. And we're going to add on to that our derivative of a this time, 6 times the cosine of 2x times b, which is e to the power of x. And we can now have that as the derivative of u, right? So the derivative of u is now equal to this. And if we want to take out a common factor of e to the power of x, we can do so and just write it like this. Okay? So that's now our derivative of u. So if I highlight all our key terms in yellow, we have our u, our v derivative, and our derivative of u here, okay, which I'm going to write like that. So we had to do the product rule inside of the quotient rule sort of thing, right? So to find our derivative of u for the quotient rule, we had to actually do the product rule, okay? So now that we have our terms, well, now we can just substitute them into our quotient rule. Okay, so we can substitute this uv, u dash v dash into our quotient rule. And our quotient rule is here. Okay, so we're going to do v, which is x squared, times the derivative of u. Okay, so there's a lot going on there. So we'll get e to the power of x outside of 3 sine of 2x plus 6 times the cosine of 2x. Okay, And then we're going to take away from this u times the derivative of v. So we're going to take away 3e to the x sine of 2x times the derivative of v, which is just 2x. And we're going to divide it all by v squared, okay, which is just going to give us x squared all squared is just x to the power of 4. Well, now let's come over here and let's crunch these numbers and get a simplified solution, okay? So if we bring out a common factor of e to the power of x on all of this, okay, so we're going to get e to the power of x on the numerator, e to the power of x outside of x squared times by 3 sine of 2x plus x squared times 6 cosine of 2x, okay? And we can take away, inside of this brackets, taking the common factor of e to the power of x out of here, take away 3, or we're going to take away 6x, because we're going to multiply this 3 and this 2 here. Take away 6x times sine of 2x, okay? And we're going to divide all of that by x to the power of 4. And I might just leave it there. That's probably enough simplifying, okay, because it's quite a chunky question there. So that's about it for the product rule and the quotient rule, okay? There's finding the numbers, the u and the v, isn't too difficult, okay? You can sort of read them off the page. We then have to use all the derivative stuff that we found to be able to find the derivatives of u and v. And then if we get a really tricky question like the last one I did there, that's about as hard as they'll sort of get. We then have to even perhaps do the product rule inside the quotient rule, or the quotient rule inside the product rule, okay? So that's it for this video. Next thing we'll move on to is the chain rule. Very good. Thank you.